we take a look at 6. We want to first list the transformations. So when we list the transformations, our parent function, what I like to do, I look at where the vertex moved. Our parent function vertex starts at 0, 0. So I'm just going to put a point at 0, 0. That, to match up with the new vertex, went right 3, up 1, 2, 3, 4. So we went right 3, up 4. Then I look and see, well, how's the graph opening? It's opening down. So whenever it's opening down, that means there's a reflection over the x-axis. Then it says, which of the following represents the graph shown? Well, I like to write down the vertex, which is located at 3, 4, and it's opening down, which means there's a negative out in front. So when I write my equation, it's y equals, there's a negative out in front, x, the x value changes sign, the y value stays the same. So the one that matches is B. If we take a look at 7, it says the graph of f of x is shown below, which is x plus 2 squared minus 4 on 2 separate grids. I'm going to sketch the graph of each transformed function, and I'm going to write the new one in vertex form. So this first one is saying, hey, reflect that graph over the y-axis. Well, here's the y-axis. I'll make that a little bit thinner. That line. There we go. We just count. So when we count, each point, see how far it is away from the y. So this one right here is 1, 2, 3, 4, 5. So we count 1, 2, 3, 4, 5. This one's 1, 1. This one's 1, 2, 3, 4. 1, 2, 3, 4. This one's sitting on the y-axis, so it stays 1, 1. 1, 2, 3. 1, 2, 3. 1, 2, 1, 2. So I just like to use the counting method. And there is our equation. So we write it in vertex form. It's y equals, it's opening up, so it's positive, but our new vertex is at 2, negative 4. So our new equation is just y equals x minus 2 squared, change the sign, minus 4. Again, I know we did a reflection over the y-axis. You don't need to put a negative on the inside. It's already kind of taken care of. You just write based off what the new equation looks like. Take the next one. This one's saying, hey, reflect over the x-axis because the minus sign is out in front. Here's the x-axis. And again, you just count. This is 1, 2, 3, 4. 1, 2, 3, 4. This one's 1, 2, 3. 1, 2, 3. 2, 3. 1, 2, 3. Again, keep counting. This one's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Same thing with the other one. It will end up right here. So the orange graph's our new equation after it's been reflected over the x-axis. This time it's opening down, so we put the negative. X, our new vertex is at negative 2, positive 4. So that changes signs, and this one stays the same. There we go. The last set of questions here. State the vertex of each of the following parabolas, and then list the transformations, and then we're going to sketch a graph. So our vertex on the first one is 0, negative 6. There's nothing on the inside with the x. They're not adding or subtracting anything. And then the number on the outside is negative 6, so it's 0, negative 6. The transformations, there's a minus sign on the inside, so that means we have a reflection over the y-axis, because there's a negative on the inside. And then we went down 6 because we're subtracting 6 on the outside. So when we reflect over the y-axis, the original graph doesn't change. The parent function stays the same because it's symmetrical with the y-axis. So really all you have to do is just take that vertex and move it, which is at the origin, just move it down 6 and then graph the rest. Again, using that up 1, right 1, up 3, right 1, up 1, left 1, up 3, left 1. And there we go. Next one here, the vertex is at 2, 3. And the transformation, there's a minus sign on the outside, so that's a reflection over the x-axis. And then they were minusing on the inside, so that means we went right 2. And then we're adding on the outside, so that means we went up 3. So what I like to do is just plot my vertex, 2, 3. And then the graph is opening down because it's a reflection over the x-axis. So you just count down 1, right 1, down 3, right 1. You just count the same way, but we're going down because it's opening down. And there we go. And the last one here, the vertex is -3, +5. The transformations, again, we have a minus sign on the outside, so it's a reflection over the x-axis. Again, we have that minus sign here on the outside. We're adding on the inside, so that means we go left 3. And then we're subtracting on the outside, so we go down 5. When I graph, again, I plot my vertex, -3, +5, and it's opening down. So it will look like this. And there you go.